This video will be a quick lecture over section 1.3, which is on frequency and frequency tables. These are concepts I think you're already familiar with, but maybe you wouldn't use this terminology to describe them. So we're going to really quickly go through a couple of examples just so you can get used to using this new vocab. First, the definitions. The frequency of a data value is the number of times it occurs in the data set. So if you count the number of times that a value of the variable repeats inside the data set, that is what we call the frequency of the value of the variable. It's how frequently that value occurs. A frequency table pairs values of the variable or classes of values with their corresponding frequencies. So first, what do we mean by pairs? Well, we're going to make two columns or two rows. You can make this table either vertically or horizontally. In one column or in one row, we're going to put the value of the variable. And in the corresponding column or row, we're going to put how often that value of the variable occurred, its frequency. When I talk about classes of values in my definition, I mean like an interval of values. So rather than just doing individual numbers, you might use intervals because the numbers are kind of spread out and they don't really repeat. So instead of giving each individual value its own row or its own column, you might lump things together and create what we call a grouped frequency table. I'm going to do one example of each, one where we're ungrouped and one where we're grouped. Here's an ungrouped example. I've got a list of numbers here that range from 4 to 10, and they represent scores on the 10-point quiz in some class. So we can see that the numbers aren't really spread out. Again, they range from 4 to 10, which is only 7 different classes, 4, 5, 6, 7, 8, 9, 10. And if you look carefully, you'll notice that one of those numbers doesn't occur, but I still want to take that into consideration because it is in the range. Breaking these into classes seems kind of silly because they're so close together. So I'm going to create a frequency table by drawing two columns. And on the left side, I'm going to put the score on the quiz. And on the right side, I'm going to put its corresponding frequency, which we often denote by a lowercase f. I'm going to take each score and give it its own place, starting with the smallest, which is 4. And again, if you looked carefully at the list of data before I started, you'll notice that there aren't any 5s, but I still want to list 5 and increment by 1 all the way up to the largest value. Now I'm just going to go through and count how many times each of these values occurs. So going through the list, I see 1, 4, and no 5s as I mentioned, so I'm just going to give that a frequency of 0. Putting that 5 in there gives me an even spacing between the values of the variable on the left. And that's preferred to skipping over those and having irregular intervals between your rows, between your classes. Now, how many 6s do we have? I see just the 1. Just 1, 7. Man, this class did well. 8s. I see 1, 2, 3. 9, I see 1, 2, 3, 4, 5, 6. And with 10, I see 3. By organizing the data, we get a pretty good picture of what's going on rather than looking at the raw data. When you look at the raw data, a couple things might pop out at you. Like you might have noticed that there aren't very many low scores. There's nothing below a 4. You may have noticed that there seem to be more 9s than anything else. But you don't have to guess at those things when you look at the frequency table. When we look at the frequency table, it's very clear that the scores are bunched up on the high side of the range. There were 12 scores at 8 or above and only 3 scores below. You can see that really quickly. You can see that there are no scores below 4 because we didn't even list anything below 4. So by organizing this into a frequency table, we get an easy to interpret representation of the data set. It's informative and organized. We call this an ungrouped frequency distribution because each value of the variable got its own row, its own representation. We know the frequency of each and every individual value. We didn't group them together into classes. Why did I choose not to do that? Well, there were only 7 different values, and having 7 rows isn't really that prohibitive. Also, there was some repetition within each of these values. If these all only occurred exactly once, then it would be kind of silly. But because there was some repetition on the high side, using an ungrouped frequency distribution works well. Let's look at an example where maybe trying to go with an ungrouped frequency distribution would not be a good idea. In this example, we're going to look at the number of views for videos of a popular YouTuber, and these are all measured in millions of views. So this first 20 means 20 million views, and this 65, which is the largest value in the set, means 65 million views. So this person creates content that gets a lot of views. Looking at the raw data can be a little bit daunting. Again, you can catch some things. It seems like there's a lot of data in that 30 to 39 range. I can see the smallest value is 18 and the largest value is 65. Of course, here to make the example nice, I chose a small data set. If you were doing this in real life, your data set could have thousands or maybe even millions of values, and you wouldn't be able to just quickly look at it like this. In order to easily analyze the data, you'd want it organized in some way, perhaps using a frequency table. So we're going to create a frequency table for this, but before we do that, we notice that making an ungrouped frequency table would probably be a bad idea. If the smallest value is 18 and the largest value is 65, that's going to give us over 40 rows of information. And a lot of those would be empty, and there isn't a whole lot of repetition. Most of those rows would only have a frequency of 1. I can see that 33 has happened a few times, but most of those only occur once. So we're going to want to group these. While there are some formal rules, I'd rather you just use one guideline and some intuition. First, let me give you the guideline I want you to go by. A typical frequency table will have 5 to 20 classes, so 5 to 20 rows or columns, depending on how you organize it. Because I tend to organize my frequency tables vertically, I'm talking about rows here. But you could make it so that things ran horizontally, and therefore you'd be counting columns. Now, how do you know how many you want? This is where I want you to use intuition. We don't have very many data values here, and they're not especially spread out, so a lower number of classes might work here. If we had thousands of pieces of data and they were significantly spread out, we might want to go with more classes. So we're going to go on the low side here and take that minimum of 5. How do I know how to choose lower and upper bounds for the classes in order to get the desired number of classes? Well, you can do a little bit of arithmetic for that. I'm going to identify the largest value in the set, which is 65. I find the lowest value in the set, which is 18. I subtract those to figure out how spread out the data set is, and then I divide by the desired number of classes. And this is not a calculation I'm going to ask you to do for points in our class. Since the invention of computers, there have been programs that will help you come up with frequency tables. So this isn't something you really have to do by hand anymore. You can just find the appropriate software, tell it how many classes you want, and it'll bang out this arithmetic for you. But I just wanted to demonstrate it for you real quick. So let's see, this is 47 divided by 5, which is 9.4. Now if I round that down to 9, then I'm going to wind up with 6 classes. So I'm going to round it up to 10. Now, I don't have to round it at all, as a matter of fact. I could use what's called a class width of 9.4, but I'm going to round that up to 10. I'm going to use what's called a class width of 10. 10 is also a nice, neat number. After all, our counting system is in base 10, so it kind of feels natural to use. Okay, so let's create our table. Go to the next slide where I still have all of the data. We've decided that we're going to run with a class width of 10. I'm going to make my table. On the left, I'm going to have the number of views in millions. And on the right, I'm going to have the frequency. My first class has to have a lower bound of 18 or less, or else that piece of data isn't going to fall into my set. I'm just going to start at 18. And now here comes a slightly tricky idea. I know we said the class width is 10, but I don't want to add 10 to the 18 because that's actually going to put 11 numbers into my list. If you count the number of values from 18 to 28, including both bounds, that's actually 11 numbers. And so I only want to go up to 27. That gives me a class width of 10. If you're not convinced, count from 18 to 27 and see how many numbers there are. There'll be 10 numbers in that list. You can see the class width in the table by seeing how much we add to go from lower bound to lower bound or from upper bound to upper bound. The next class is going to begin at 28, and there's that class width of 10 when you subtract the lower bound of the second class and the lower bound of the first class. And we'll just continue to create classes until we get past the largest value, and if we did our arithmetic right and didn't round too liberally, we'll wind up with 5 classes. And you can see we've achieved our goal. We have 5 classes, and the first class includes our smallest number, and the last class includes our largest number. So every piece of data is going to get represented in the frequency table, and we got the desired number of classes. We got the 5 classes that we wanted. The rest of this is just carefully counting and making sure that we find the frequency of each. And again, in the modern age, we don't need to do this by hand. You just input the data into a calculator or a computer, and it'll do the counting for you. But I chose a small example here where it won't take very long. I'm not going to make you watch me count all of these. I'll go through one of them, and then I'll just skip ahead to the end. It might be a worthwhile exercise to double check my numbers. That's up to you. So let's see. For the class from 18 to 27, well, 20 is in that range, and 26 is in that range, and 27, we're counting that, we're including the bounds. Let's see, 19 is in that range, and there's the 18 that we wanted to start with. And that looks like it. There are 1, 2, 3, 4, 5 total, and so that class has a frequency of 5. I'm now going to go through the rest, but I'm not going to make you watch me do it. It'll magically pop up on the screen. And again, if you think it'll be worth your time, you can double check that I did it correctly. Here's the completed table. One thing I did behind the scenes to double check is I added up all of my frequencies here. They add up to 24, and there are 24 pieces of data. That doesn't guarantee that I did it right, because I could have a couple of mistakes. But if this column did not add up to the total number of pieces of data, then I definitely did something wrong. Not something you really have to look out for in the 21st century, because you'd probably have this done using software. Now we can analyze the finished product. We can see really quickly that the most common range is that 28 to 37 million views. Almost half of the videos fall in that range. There aren't very many on the very high side. The biggest range only had one video that fell in that range. And one of the drawbacks to a group frequency distribution is we have no idea where that piece of data is. It could be as small as 58 or as large as 67. We have no idea. But going with an ungrouped frequency distribution just wasn't an option here, because we'd have so many rows that would have zeros in them. It honestly wouldn't be much better than just looking at the raw data. It was definitely better to go with a group frequency distribution. Should we have used more classes? Perhaps. Maybe we could have broken this up a little bit more. I also think we would have wound up with a couple of 0 rows though, and while that can't always be avoided, if it can be avoided, perhaps it's worth it to do so. In a future section, we're going to take this a step further and talk about how we can turn this into a graph that we call a histogram. For now, I just want you to be familiar with the two terms frequency and frequency table, and have a vague notion of how they're created. We want a typical frequency table to have 5 to 20 rows. Not too few, not too many. 5 to 20 is kind of the rule of thumb when it can be done naturally. Let me know if there's anything you want me to clear up.